David Cann here with another question bank question in the style of what you find in your Hayes&Harris Math SL textbook, Chapter 9b. We're looking at applications of the sine and cosine rule. In this case, it's the cosine rule. In this question, we're told about two boats, A and B, that start moving from the same point, P. Boat A moves in a straight line at 20 kilometers per hour, while boat B moves in a straight line at 32 kilometers per hour. And the angle between their paths is 70 degrees. We want to find the distance between the boats after 2.5 hours. So we'll start with point P, and we'll say that boat A moves in a certain direction, boat B moves in a different direction, and the difference between them is 70 degrees. After 2.5 hours, each boat is going to have moved a certain amount of time. Distance is equal to velocity times time. So given their velocity and time, we ought to be able to find how far they moved. So the distance for boat A should be equal to the velocity for boat A. That'll be 20 kilometers per hour times 2.5 hours. When we perform that calculation, we'll find that hours cancel, and we get 50 kilometers for boat A. For boat B, the distance that boat B travels, that'll be the same calculation. It'll be the velocity of boat B times the time taken. The velocity of boat B is a little bit different. It's 35 kilometers per hour. Multiply that by the same 2.5 hours of travel. Once again, hours times per hour cancel. And we get 35 times 2.5, or 80 kilometers. So what this tells us is that boat A travels a total of 50 kilometers, and boat B travels a total of 80 kilometers. And there's a distance between those 2 points. That's the distance we want. We'll call that distance C. So what we'd like is the third side of a triangle with two known sides. To find the missing side, it'd be nice if we could use Pythagorean theorem. Since it's not a right triangle, though, we'll have to use the cosine rule, which is Pythagorean theorem for non-right angled triangles. The cosine rule tells us that side C squared is equal to side A squared plus side B squared. And that's just like Pythagorean theorem. But then we'll throw in a factor for the non-right angle triangle, and that's minus 2AB cosine of angle C. Angle C being the angle opposite side C, or the angle in between A and B. And so C, which is the angle that we want, or the side that we want, is equal to side A, which in this case is 50 kilometers, plus side B squared, which in this case is 80 kilometers squared. Take 2 times 50 times 80 times the cosine of 70 degrees, because 70 degrees is that angle between side A and side B. It's also the angle opposite side C. Now, 70 degrees is not one of the major angles on the unit circle, so we're not going to have this solution memorized. Instead, we'll turn to our calculator, we'll plug in, making sure that we're in degree mode, and we'll find that when all of this is entered, it works out to about 6,164 square kilometers. To get just C, we'll have to take the square root of each side, and so C will be 78.5 kilometers. Now, whenever you take the square root, you need to remember plus and minus, but since we're talking about distances here, we can quite easily throw away the negative solution, leaving only positive 78.5 kilometers. Taking a quick look at the solution, we see that they were looking for some sort of diagram for a hint to the method, or they were willing to accept some working where you found the distances involved by multiplying the time by the velocity. And then finally, for your last marks, they wanted you to use cosine rule to find that missing D, plug in exactly as we did and solve to get 78.5 kilometers.